Good morning, students. This is the Monday morning. We are down to the last 2 weeks of school, when we actually should on this algebra finish up a little early because we will be through lesson 118 and by the weekend. I won't finish up too much early, but maybe a day or so early. And we have taken the whole book as a challenge, and we were going to complete it, Lord willing. I want to challenge you this morning with putting your whole heart into these last 2 weeks. Sometimes on a race, we call the last distance that we run a sprint. And so we are going to put our whole heart into it and do our very best as we go down the home stretch and complete it well. I'd like to have a short prayer with you. God in heaven, I just pray that you'll help all these students as they complete this algebra assignments, lessons, that they'll put their heart into it, give them clearness of thinking, help them to understand that all of life is meant to be a challenge to do our very best, our very, very best for you, God. Just thank you for the beautifulness of life that we can enjoy because of you. Give us strength and grace for this day, through this week. Bless the teachers as they teach. In Jesus' name, amen. Here we go, lesson 113. If you are ready, we are learning something new this morning that is, I love it. It's kind of a challenge. We are learning about ratios and a couple key things here. Let me just note here. So you can get this. Please sit up now and take careful notice because I'm going to show you a couple of things that are important on learning these concepts. Well, we'll be doing this for a number of lessons. We have two different things that we solve with on ratios. One is called direct variation, and one is called inverse. These are the two different ways we solve for these. Inverse variation and direct. Those are the differences. What do they mean? I think of direct as in a straight line, so we will have something like a formula, something like this. One position equals this times this. This is in a straight line. Direct, does that make any sense to you? Hopefully it does. Inverse is a little different. When we think of inverse, often we think of it as a fraction, and our positions will be something like this. This is inverse. This is direct. Does that make sense? Straight line is direct. When you read in these problem sets, you're going to see that word direct, or else you'll see the word inverse. That is strong in your mind. I'm going to let that there for a moment. Direct is in a straight line and it has multiplication, and inverse is a division problem and it's in like a fraction form. Watch for these two words. So key. When we start the problem, when we start reading the problem, those are the two key words. Now we have something else. This is one more thing I want you to really get a hold to. We'll have a position called a K position, which means constant. We find and establish the K position in these problems, and then once we find that and establish it, that K position never changes. It's a bit, possibly we could refer to I think of God. God never changes. The K position is a lot like that. It never changes. Once we establish it, if we discover that this number is 500, then as we work out the problem, on into the problem, as we work it out, remember, this never changes. The K is a constant that never changes. Is that understood? Keep that in your head. So important. Do not change the constant. All right, here we go. Number one. Number one is our first problem. It says to travel a given distance, the rate is inversely. Do you see the word inversely? What kind of a problem is this? Inversely is going to be a problem like this. Is that correct? That's what we learned to start with, okay? Erase that. It says, usually I just start off with writing things down. You can change them around as long as you keep this position. It said that you noted if you drove at 100 kilometers per hour, just put that down, 100 kilometers. It must equal, remember this is inversely, so we're going to have that type of problem. They've noted that the trip would take 5 hours. 5 hours. 100 kilometers equals that. How can we solve? Now we have one position missing, right? We have two of the three. We have one position missing. The one that we have missing is the K position. And now tell me what we said about the K position. It means constant. Once we establish this, what do we say about it? It is like God. It never, 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 never changes. What do you think the answer to this is? 100 kilometers, 5 hours. In other words, what number up here divided by 5 equals 100? Another way to do it is multiply this. Is that 500? Now, is this a true statement? 100 equals 500 divided by 5. Is that correct? It is. All right. What about this number? This is the only one we are not going to change. The others will change. And they tell us that. How long would it take him if he drove 125 kilometers? This is 100 this time. We're going to change this to 125. Now, is this still a true statement? It is not. So why don't we change this number at the top here, make it true? Because the constant never, 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 never changes. Y'all got that? That's important. Okay, so here we go. We're going to erase this 5. Now then, what would make this statement true? 125 kilometers equals 500 kilometers is your constant. What makes this true? Now, is that true? 500 divided by 4, does that equal 125? It does, so here is our answer. Did y'all get the idea of all of this? Here we go to the next one. The next one is number 2. The mass of a substance varies directly. What kind of problem is that? Is that inverse? It is not. It's going to be solved on a straight line as in. Okay, so we want to find the positions. Now, on a straight line formula, one of the keys to this is always put your biggest number first. It says if the mass of 7 liters of substance is 42 kilograms, which one of these numbers is the biggest? I see the 42, so I'm going to go 42 kilograms equals, and this is going to be, your constant is right here, times 7 liters. Okay, so we need to establish for the constant every time. Once it is established, it will never change. What times 7 equals 42? Is this correct? 6. 6 times 7, does that equal 42? We just made that a true statement. And we also established a constant, which, I'm going to keep saying it, it never changes. Don't ever try to change your constant. So now we have 6. 6 times 7. We will be changing the other two numbers. What are we going to change it? What will be if the volume is 63 kilograms? So here we're going to change this 42 to 63. 63 kilograms. This 7 is no longer true. Why don't we change this number right here? You want to change that? You better not want to change it. That's a constant. It never changes. We're going to change this number out here. 63, 6 times what equals 63? Well, now they didn't give us a whole number here. And that's okay. You can either just figure this out in your head with that computer up in your head, or else we can do the division. In this case, I'll just show you. Do the division. 6 is 1, 0, 3. 6 goes into 3, 0 times another 0. 6 goes in 35 times. That's even. So our answer is 10.5. And 10.5 of that is liters. Is that correct? So your answer, make sure you put the right labels on these. Is that beginning to make sense on these? We have 2 more, hoping it does. Okay, number 4. The distance traversed by a car traveled at constant speed is directly proportional. Is this an inverse? It is not. It does not say inverse. It says directly. So we're going to have this type of a problem. Remember that. And if it has that kind of a problem, which number do we put first? The smallest or the biggest? We always put the biggest one. If the car goes 90 kilometers, makes sense. It equals, this is your constant position. It equals, and they do that in 9 hours. All right, let's establish here for the K position. What is the K position? Am I right that it's 10? 10 times 9, that makes it a true statement, so we have a 10. All right, I'm going to keep on stressing and stressing the important things. This is our K position. What is important about the K position? Let me hear you say it. It never, never, never changes. So we've established it. The other numbers will change, but the K position will not. It's 10, 10, 10, 10, 10 from now on. All right, so now it says, how far will it go in 5 hours? This was 9 hours. So we're going to change this position because that's what they're asking. Change that to 5. What does that make this number? How far will it go? It will go 10 times 5 is 50 kilometers. There is your new answer. They're kind of fun, huh? We got one more. Peaches very directly is directly. Yes, directly is always, I'll keep doing this till you get it. Directly is on a straight line. Here we go then. So Peach is very directly now. Always, what do we do? To put the biggest number, the smallest number on this side. The biggest number. So the apples are the biggest. I'm going to put the 120 equals. Again, this is your constant. We'll establish for you. With equals 40 peaches. So we put this P and the A here, maybe to keep us from getting mixed up. All right, what is the number for the constant? What times 40 equals 120? 3. All right, so now we've established the constant. And the constant, I'll keep us saying it never, never changes. So we're not going to change the constant. It is there permanently on this problem. Okay, so how many apples went with 500 peaches? Here was 40 peaches, and they're asking us to change this now to 500 peaches. 500 peaches. Now that's obviously not a true statement anymore, but 3, this constant does not change. 3 times 500 equals what? 1,500 apples. There is your answer. How many apples went with that? That is number 6. That's the end of the new stuff. I'll go over a couple of the ones that you might still have questions about. Number 7, sketch the graphs of the following functions: A, B, C, and D. And these are graph the functions. Remember, we do our simple little graph. There we go, and the first one is A, and this one's very similar, and this one is, I like to write them the other way around if that's okay, +1, and this one is a x plus 1 with absolute values. Okay, what kind of a graph is, or what kind of sketches is the absolute value of x? Remember, we have 2 straight lines. I'll do it over here. It's this kind of a, with the arrows. Do you remember that? We studied that in the previous lessons. That's the type of graph it is. Okay, so there's no number included with that. We're going to start off right here with this center 0 line, and we go this way. That's on A. This is very similar, no number with it. It started off with this, but it is a negative, so we're upside down. This one has a +1. That is on the Y line. And on the Y line, it is a +1. Where is a +1 on the Y line? Right here. I'll even put that there. This one goes there. And whenever you have inclusive marks, which is absolute value, parentheses, square root signs, anything that is inclusive, then we use we go to the X line. This is Y when it's out in the open. When it's inclusive, then we use the X line. So here we're going to be on the X line on this one. And also it changes this number. It's +1, it's going to be a -1, right? Here is a -1. So we will go from here up this. And there is number 7. Number 9, This is from the previous lesson. This was a little more complicated stuff, so we'll work through a couple of these. 2 plus square root of 3 times 4 negative 5 to the square root of 12. Correct? Multiplication. 4 times 2 is 8. 4 times 1, that's understood to be 1. 4 is a positive 4 to the square root of 3. Now this one, negative 5 times, that'd be negative 10 to the square root of 12. And one more, this is always most complicated. Negative 5 times 1 is a negative 5 times 12 times 3 is a square root of 36. Start simplifying. This 12 right here, let's see if we can reduce it. 2, 6, 2, 3, we can. So that's going to be 2 times this negative 10 is a negative 20 to the square root of 3. 36, what is 36? The square root of 36 is 6, so negative 5 times 6 is a negative 30. This one cannot be reduced, and this cannot be reduced. Now we can combine. We have an 8 and a negative 30. That is a negative 22. And we have a positive 4 and a negative 20 to the square root of 3. That is going to be a negative 16 to the square root of 3. That is for number 9. Number 10. 2 positive square root of 2 times 4 negative 3 to the square root of 8. That is a poor 8. Okay, start right here. 4 times 2 is 8. 4 times 1 is 4 to the square root of 2. Now this way, negative 3 is a negative 6 to the square root of 8. Last time, negative 3 is negative 3 to the square root of 16. All right, let's see if we can reduce any of these. I believe there's 8 we can. 2 is 4, 2 and 2. So we have 2 times negative 6 is a negative 12 to the square root of 2. 16, square root of 16 is 4. That is a negative 12. If you multiply that, negative 12. This one is not changeable, and neither is this one. Now we're going to combine numbers. 8 and a negative 12 is a negative 4. And a positive 4, and that's going to be a negative 8 to the square root of 2. Did we do that one right? That is correct. That is number 10. Number 11, 5 positive square root of 6. I'm not going to completely work this out. I'm kind of running out of time here. 2 negative 3 to the square root of 24. Remember, we multiply first off this times this, and then this times this times this, and this times this, and that is get your answer. That and you can find the answer in the back of your book, so I'm going to let that go. All right, number 12. I'll do that one for you. This is the original. Positive 5 and 3. And remember to always establish your domain is reals on this one. Okay, what we need to do is get rid of the positive 5. Move to the outside, it becomes negative 5 and a negative 5. So now we have a negative 7x, and this is a negative 2. Is that correct? And this was, sorry, just got to squeeze that in. Okay, put that on your number line as 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. And we will go all the way out to 7 here with a, this is -6. This is going to be a closed because of the equal sign, and this one is an open. Let's combine those together. All right, and number 13, I'm going to skip that. Maybe I'll go to number 28 yet. That one might be a little more complicated. It has A is a equals 3, B equals 3, and C equals what? If here's the original 4C -1 equals 1. How do we get rid of the C, the 4, so that the C would be by itself? This is the way we do it, of course. We have the 1, we move the 4 underneath, so C equals 1/4. I think I'm going to leave that with you on 28. I think you'll know how to do that. You cannot, I'll just give you a hint on this one. You cannot solve this any further than, I'll tell you what I'm going to do. I am going to actually give you the final answer, don't you? But you, because this is 28, and you just come up with it. -3 plus or minus square root of 6 over 6. That is the answer. I want you to use this, work that back, and check yourself out. Understand? Kind of run out of time here, so I want you to have a wonderful, blessed day and a wonderful week. Keep your head up. We're down the home stretch. We're going to win. That's what we can say. And hope to see you tomorrow morning.